Welcome to a new test and teardown video. This time it's an ESI Universal Impedance Bridge model 250DA. I believe this one is from about 1967. I'm actually a little bit unsure because we got quite a lot of different models depending on the meter and the way that the different knobs and stuff like that looks like. You also got some with a indicator or something like a sticker label around those two switches here. And what else can I say? This thing is quite nice. It's 7 kilos with the lid and cable. And inside the lid, there's a full documentation of everything here. We should probably zoom in a little bit and present some nice close-up shots of the different details here. Like I said, it's a bridge. So that means we're comparing known values with unknown values, and then we're balancing to a zero difference, and then we know the unwanted value, what that will be, right? And of course, if you put in AC, you can measure capacitors or inductors, or if you do this at DC, you can measure resistors. So it's quite simple. You can also measure Q and all those kind of things. And I believe there's a readout module here at the top. And I think most of the bridge stuff we have down here is passive. There's just a mechanical readout meter here, and you can lock or unlock that meter. And you can have external DC or external generator or something like that here. And so this is the connection to the built-in readout module with a really nice magic eye. That was actually why I bought this unit at a flea market. Because of those magic eyes, they just make me go crazy. I think this is such a beautiful unit. Look at that. And a nice handle. It's not completely beat up. It was a little bit dirty, but so far, but due to all the corrosion, and it was full of leaves and such. So I feel I need to open and inspect first, and then we'll see if I can power it up. So this is here where you select the generator, internal AC, external generator, or internal DC. Detector, is it AC or external detector? Shunted meter or direct meter. And then that will be all the resistors. We are comparing with the resistors, right? So look at that. So if we are in R times 1 or times 10, I kind of love the way. Look at that. This is so nice. And then you go again down here. So if R is times 1, then we can read the exact values here, but then times 10 you can move everything a factor of 10. And then you set up your value. This is almost like access to a vault. This super nice switch. I love it. Yeah, let's open and have a little inspection. I think it's quite nice. You can find another ESI unit on eBay for $75. Plus shipping, obviously. So while I'm doing the unscrewing here and getting in here, I realized that, look at this, this is an oscillator. This is how it's mounted. And then you pull it out, so there's a connector here. So that's all there is to it, a tiny little oscillator that goes in here. Oops. And then over here is an amplifier, a 1 kilohertz amplifier. And it works the same way. You can't mount it that way because of the connectors, so they made sure about that. But we definitely need to open these and have a little look. That was a little bit unexpected. So this is supposed to be the oscillator. All I see is resistors and capacitors. That's all there is to it. So this is probably what set the oscillator parameters, or the frequencies set up. So that means if you change this to another type, you can set up another frequency. So that is not too bad. So this is inside the amplifier module, and I believe that will be more or less the same kind of components. It's different resistor values, but again, we got quite a lot of capacitors and resistors like that. It looks like a filter of some sort. So this obviously defines just the frequency of the amplifier. So again, if you change this, you can make the detector and amplifier and everything work at a different frequency. All right, so we are learning a little bit of things so far. You're going to love this. It is absolutely beautifully made inside. That will be the Q. 3 different ranges here, right? Oi, 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 this is nice and beautiful. There's another interesting sticker here. February 1964. So now we know exactly how old this is. Got some other stickers here. This smell is intense. You can see a little bit of spider webs here. I will spare you the photos from the internal of the cabinet because it was full of 5 or 6 different animals, some funny dead critters. So that I will have to go and clean outside. That will be the resistor potentiometer here. Look at that. Is that just a beauty? Let me do that. Oi, 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 oi. That is something. And the feel here is just click, click, really, really nice. I totally love it. And that one is, of course, in here. The same super nice feeling. And then that is a little bit, that's all right. So the potentiometer is all the way here at the back. See the shaft that goes here. This is a special type that allows you to go, let me show you, that shows you, that allows you to go all the way around. See here, it's normally a click. So this is minimum, click maximum, but instead of having a stop, you can just go this way. Quite nice. So this is intentional. I think that normally there's a lid covering the bottom here. That maybe just fell off because it's, I don't see it with this model, but there's definitely supposed to be a lid here. Well, here we go with the 3 tubes. Everything looks quite all right. I'll probably have to take my little duster and clean it nice and fine. capacitors don't seems to have leaked or anything like that. So we've got some selenium rectifiers here and here, but everything looks like it's in a good state of health. Yeah, and that again, you see, so we got one that is the oscillator and one that is the amplifier, detector, gain, that's driving the magic eye. I can't wait to power this up. I forgot to talk to you about the meter. See this long stick here at the back of the meter? That is because this meter is not a standard meter, as you know. The spring is not a coiled up spring like a conventional meter, but it's a long, straight spring that twists a little bit. And they are actually a little bit more linear, but they stopped making them because of the size. So back in the 60s, that will be the most linear, most accurate meters that's made like a galvanometer. So the needle is actually hanging freely in this long, flexible piece. There isn't any like a bearing or anything like that will cause disturbance to the readout. And that is also why you have for transport this lock. As you can see now, the meter is locked. So if we unlock it, how is it done? Like that. Ah, it's because it's hanging like that, right? Let's have a look. How's that working? Yeah, see? I am not lucky with that. It's probably only going to work when it's lying flat. So I think we need to have a little look inside these two boxes. Magic secret boxes, right? Well, that was boring. So we just have probably a mains transformer driving the primary, and I don't know exactly how this is working, but that's probably our AC injection or something like that, right? So it can also work on internal AC. So it's working on mains frequency, right? But what is inside this funky shiny box? I have no clue. And it's sealed, soldered, sealed. And then we got a few capacitors down here, and then just two wires. So, so far, no clue what is in that one. I better put it back again. So let's dim the light. This is the first power on. I believe that everything is left on. So all I have to do is crank on mains like that. And we have a very powerful power on indication here. And that is the amp. Oh, we also see some green. What I did is, I think I set it up for external generator, external detector, and times 1, and then 1K down here. And I also believe that I set this for 1.000. So I mean, this should be set up for 1K as well, right? So all I have to do is see if I get, I don't know what that is. This is the oscillator level, maybe. I don't know. Oh yeah, this is the drive. I can actually hear. You can hear the tone. So it is running at 1K, 1 kilohertz. So this is the amplifier. We got a little bit of noise in that potentiometer, right? So if I crank around here, no. Big bummer. I was hoping. Oh no! Why don't you work a little bit? So this is 1. Why don't you work? No, how sad is that? Shunted meter in external. Oh, how funny is that? I'll have to play a little bit more with this. Obviously, okay, at least here we have a little bit of some response, right? So let's go. Oh yeah, look at that. See all the other, oh, look at that, right? Oops, sorry about that. Here we go. 1, and then 0.0, and then I have to go for, see? That is 1.000 or something like that, right? Haha. I should definitely. And then you hunt the smallest signal. So that is what I need to do. Okay, so internal AC generator is what I have to do. And then what is this doing? Okay, so external detector is the right thing to do. Okay, so we are learning some things about how this works. I'll probably have way too much amplification. See, there's a nice indication here. Wow, man, it really works. How nice. So before anything blows up, maybe I should document power consumption is about 12 watts. I am really happy about this. Now I'm gonna go and deep clean everything. Probably going to learn how to use L and C and stuff like that, but that is not going to be super interesting anyway. So let's try and test a capacitor. This one reads 1 microfarad, but just to be sure whatever it is, I also tested here at 1 kilohertz. So it is 101. All right. I don't know how easy that is to see, but I had to crank up the amplification here to get much more sensitivity. So that is pretty cool. Otherwise, with the lower sensitivity, see, it only responded to the big one here. So this is 1 click 1, and then we have the lowest possible. I'd like to see here, and then I go down to 1.0 for the lowest, like that, right? And again, the last digits almost no. Okay, you do have a little bit of something, but again, it is best at 0. So I think it's what I'm doing here is a little bit stupid. I should find a capacitor at 1.2 or 3 or something, so I can see that I'm not in the middle or at the end of the readout, right? I think that should do it. This one is 2.36. Okay, let's play. Aha. So that is 2. So the idea is you dial this, constantly seeking the lowest. I don't have much response at the last digit, but it is 2.3 at least, right? So that's not too bad. Let's see if I can get, yeah, more oscillator. Now, I mean, you need to be really, really good at looking at the detector. You could also mount an external detector here at the banana plugs and then get the last digit. So I bet you could do that. But so far, I believe this thing works. And it's still accurate. Lucky me. It's real nice, mate. You can easily pull out this one, and then you can wiggle the tube real careful to get it out. So this is a Magic Eye, a little bit rare model. So this is the 6U5. It's a beautiful Magic Eye. And the socket here is the 6-pin. It's also, yeah, quite rare for a Magic Eye. I really don't think I got anything similar to this in my tube collection. So that's cool. And this one definitely works. Yeah, but now I'm gonna clean up everything here so it's nice and fine, because you can easier clean up stuff when it's out like that, right? So I'm not going to play anymore with this right now. I'm just gonna clean it up, pack it up, and make it nice and shiny again. So thank you very much for watching. Please come back soon again. Bye.